We will now proceed with the first panel for the day. Requesting all participants to kindly be seated. Securing India's mineral resources for a battery-powered future. This is the first panel for the day, and this will focus on the foundational question for India's battery ambition. How do we secure the critical minerals required to power a self-reliant battery ecosystem? As demand for lithium, graphite, nickel, cobalt, and other critical minerals grow, mineral security has become central to manufacturing and competitiveness as well as energy security.
To moderate this important discussion, please welcome Mr. Pawan Mulukutla, Executive Program Director, Integrated Transport, Clean Air and Hydrogen at WRI India. Pawan has over 2 decades of experience working at the intersection of urban mobility, energy, environment, and sustainable development. He has led several pioneering initiatives supporting sustainable transport, clean energy transitions across India.
Joining him on the stage is our distinguished panelists. First, we have Dr. R. Vijay, Director of the International Advanced Research Center for Powder Metallurgy and New Material, ARCI. Dr. Vijay has spent over 3 decades at ARCI and currently leads the center's work on advanced materials and nanomaterials. His research has been instrumental in developing electrode materials, including lithium iron phosphate and lithium titanide for lithium-ion batteries.
Please welcome Mr. Kalpesh Pandya, Vice President and Business Head, Cathode Materials, Epsilon Carbon. Mr. Kalpesh is a seasoned chemical engineer and currently leads the commercialization of innovative cathode battery materials using advanced green technologies, helping strengthen India's battery materials ecosystem. We're also pleased to welcome Mr. Sandeep Hamilton, Founder and Chairman, Critical Minerals Association India. Mr. Hamilton previously worked with the Department of Atomic Energy, Government of India, leading critical minerals exploration and research. Today, he is one of the leading voices advancing India's critical minerals agenda.
Joining the panel is Ms. Priti Shukla, Portfolio Manager, Electric Mobility at Energiva Ventures. With over 6 years of experience in the development sector, she has worked on key electric mobility initiatives such as National Electric Bus Program and eFast, supporting the growth of India's EV ecosystem. And now, we would like to invite Mr. Chetan Jain, Senior Vice President, Business Operations at Lohum. Mr. Jain is a business leader with over 15 years of experience in terms of scaling businesses across mobility, education, and clean energy sectors with a strong focus on growth strategy, operations, and market development. Ladies and gentlemen, please join me in welcoming our panelists. Over to you, Pawan.
Good afternoon, everyone. A warm welcome. And as Chaitanya mentioned, that we will now move from conversations to action. And it's an excellent panel that we have today. So Smriti, how much time do we have for this panel? 40 minutes, right? So we'll actually do 2 rounds of questions and answers, and then we'll open it up to the audience to really ask you all questions. So I'll start with Dr. Vijay, Director ARCI. Sir, I wanted to ask you that, just building upon what the Minister said and Mr. Vijay Samudrala said, that India can mine ore and even acquire it overseas. But the harder gap is processing know-how, turning concentrates into battery-grade cathode and anode active material, and separating and sintering rare earths into NdFeB magnets. Where does India hold proven, scalable process IP today? And what is ARCI's pathway to transfer that know-how to industry at commercial scale? Quite a lot of words and question into it. That how do we get technology in place to really move towards a commercial pathway?
Yeah, good morning to everyone. It's a a burning issue. So how do we get it? It's kind of a chicken and egg problem also. So which is first, and then we know which is second. But the thing is, we need to have together. And what he said is actually Honorable Minister, and then Dr. Vijay also mentioned that we are actually standing at the crossroads, and then where we need the technologies, the manufacturability, and then the scale at which it has to be manufactured. So it's all essential. So we are actually working as a government. I was also part of it in terms of the critical missions, critical minerals, metals mission. I was also part of that committee. And then as Minister mentioned that, you have 9 centers of excellences were established by leading institutes, and then we have a hub and spoke model with a lead institutes. We have in Hyderabad, we have 3 centers of excellence, one with an IIT Hyderabad, which ARCI is part of it. Then you also have NFTDC, and then CMET, then you have ISM Dhanbad, then you have NML, then you have IIT Bombay. So these are all given. Then we had a very brainstorming session, and then each COE is given as a specific task to work on, to develop, or to scale up. Not just because some of them may be developed, initiated, but many of when you are looking at all the technologies for these critical minerals, what identified, and then especially we are looking at for a battery perspective, we are looking at minerals like nickel, then cobalt, then manganese, then of course originally is lithium. Then we also mentioned that our joint ventures lithium security is established in Argentina, and even in Bolivia with our Indian companies having a joint ventures, and then so that that lithium supply security is established, and then but that's not enough. We have to have more and more. But these critical, what I'm trying to say is these center of excellences, which are all at TRL level 4, then they are asked to scale up and then demonstrate at an higher TRLs. And this is what proposals, each one is asked to work on specific things, and then establish a pilot plant, and then work with an industries also to churn out the technologies as early as possible. And that's all in the critical minerals. And then coming back to the NDFEB, the magnets, for an electric mobility, so you have 2 things which you need, both are required. One is on the battery, then is on the magnets for the electric mobility, so for the motors. But when you're looking at government also established, you are all aware that an RFP, request for proposal to establish 600 tons to 600 to 1,000 tons per annum of an NDFEB manufacturing plant, starting from the mineral to magnet, from the ore to the magnet, which is being done. And then we are also part of that in the committee to making those proposals as a rep from the Department of Science and Technology. Then essentially many companies have done it, and some of the companies, what we know is they have taken technologies from Indian labs, and then some of them have taken technologies from Japan, and then other things, some of them scouting. We know that once the deadline is over, that is extended up to June 30, then the proposals will be taken up, and then government will be given. So once we have that kind of the orders are given for the establishment, then we will have a manufacturing facility for the NDFEB magnet. It has to be done implemented in 2 to 3 years and a fast track mode. And then at ARCI, we are not working on the extraction of the critical minerals, but we are working on from the salts to the products, like anode materials, as we mentioned, cathode materials on the lithium-ion batteries, lithium iron phosphate, and then lithium titanate and all. And as well as for the next stage, next generation batteries on the sodium-ion, like sodium vanadium phosphate, or the hard carbon, what we are working on, and then which is at the pilot scale level, and then we have already signed an agreements with some companies to work on that. What I'm trying to say is, we lost some gap, by using the lithium-ion battery. That's the first wave. But then we have a chance, and then we are riding the second wave with the sodium-ion battery. And then also more or less the supply, the critical minerals, you need to have the contents what you need in terms of the lithium ion, so that it will be less in the sodium ion batteries. So ARCI, we are doing it in terms of the magnets. We have a full-fledged pilot plant to make an NdFeB magnet, which was inaugurated in the month of March, and we are working with many industries, and then even with the battery, many startups were connected, associated with an ARCI. And in India, whole and soul, so these technologies on the critical minerals extraction, it can be scaled up. So the government is also pushed up, all those center of excellences are putting up a pilot plant in association with an industry. And then given that, then we can also have a complete technologies demonstrated with a scale and the economic viability, so that mineral refining will be completely established, and then that supply chain can be done in the few years. And that's what India is moving ahead. Thank you. Yeah.
Thank you, Dr. Vijay. Moving on to Mr. Kalpesh Pandya. China supplies roughly 4/5 of the world's anode material and dominates LFP cathode. The two materials actually Epsilon is building domestically. So to be cost competitive, what does your company, what are the most need on feedstocks, whether it's demand certainty, and how do we create a level playing field against the subsidized imports? And moreover, how can domestic active material capacity scale fast enough to ensure that we are building Indian cells with domestic materials rather than imported ones?
Yeah, hi everyone. That's a that's a great question. It actually includes a lot of things around the business. Raw materials, the demand side, and of course, level playing field. So I'll just start off with you mentioned China controls 80% of the anode supply, but on the cathode side, specifically LFP, it is about 99%. So there's absolutely no capacity outside of China. There's some in Indonesia, but even that is a Chinese-owned company, right? So how did China get there? By focusing, it was a very strategic government-sponsored, focused collaboration between industry, government, and the counties coming together to realize this LFP dominance in the last 20 years, right? Now let's take feedstock, for example. And I'll just focus on LFP because that's the chemistry of choice for most Indian manufacturers today. Even for ESS applications in the US, majority of the companies are gravitating towards LFP. So let's talk about LFP then. The two raw materials that you mentioned, lithium carbonate and iron phosphate. The Chinese companies have stakes in mining across the board on both these raw materials. So for example, CATL, China doesn't have a lot of lithium mines. CATL owns quite a few in China, but the majority of mines are in South America. A lot of spodumene comes from Australia. Australia is the biggest exporter of spodumene into China. The reason is, even though they have the mines and the raw material, they don't have the refining capacity. 70% of the refining occurs in China today. So that's how these Chinese companies have built a stranglehold, because they are vertically integrated. Now, if you go to iron phosphate, same story repeats. You have very few phosphate mines. The phosphate mines are concentrated, about 70% of them are in Morocco. Outside of that, all the refining is in China. In fact, iron phosphate in China is a byproduct coming out of the titanium dioxide industry. So they have a huge titanium dioxide industry. They make iron sulfate, which is a byproduct. And out of that, they can build iron phosphate. So it's very, very cheap, very strategic for Chinese LFP, right? Now, where do we stand? So we have to import lithium carbonate. We have to import iron phosphate. Of course, with the initiative that Kabil has taken, working with Argentina and Australia on the mining side, that's very helpful. But we have to be mindful of the fact that that's just one part of the puzzle. You still need refining capacity that needs to be built for us to be able to utilize the lithium carbonate. Now, coming to iron phosphate, it's the same story. We have phosphoric acid, which is technical grade or even fertilizer grade, but we now have to move towards making it a battery grade material for us to be reliant, have that reliance in India for both the raw materials. The second part you talked about is the demand side, right? The customer side. So our customers are the cell makers. They've started, Now, this is a unique thing about this industry, right? The cell side and the battery material side have all started together. This is very atypical. They are learning, we are learning. We are dependent on them to qualify us, but at the same time, we are waiting on them to learn, and they're learning with imported materials because we don't have those materials here in India, right? So, I mean, where do we start? Chicken and egg, like Dr. Vijay was mentioning. A lot of the cathode makers now have the capabilities. I'll talk about Epsilon. We have R&D capabilities, also a pilot facility. So what is really important for the ecosystem to develop, for players, midstream players like us, to allocate funds, capital funds, to come up with a manufacturing facility, is to make sure that we have demand certainty. Part of the puzzle is, you don't have a standardized commodity product that you can just sell in the market, 99.5% grade, and you can sell it to everyone. This actually goes through a life cycle. It's a pre-sample A qualification where they test on the specifications of the material itself. Then it goes on to an application, and then it goes on to the final application, right? So and the final application is, of course, has to be tested from a mass manufacturing facility. So what do we need? We actually need our customers to work with us to qualify the material, but also at certain level, we want to make sure that there's some kind of an agreement that comes through, like an offtake agreement that helps us go to the institutional lenders and get the capital that's needed for the mass manufacturing facility. One other thing that I'd like to point out, the PLI scheme was great for the cell makers, but the PLI scheme hasn't really worked with the intention that the makers had, in that the midstream sector really is bereft of any benefit right now. Now, having said that, I would say that we've had several fruitful discussions with the Ministry of Heavy Industries in the past 1 year or so. We are very close to inching a deal with that, an incentive scheme for the midstream sector. So I think that will help out greatly. And I think the third one was, if I forget, feedstock, capital, and the last one was?
Level playing.
Level playing field, yeah. So this is another interesting one. If you just calculate the disability today on a cost basis, right, vis-a-vis Chinese product, we are at about 35% disability. That's huge. The reason why you don't see it in the Chinese unit price is because there's a stack of subsidies, right, at every level. Capital subsidy, land, building, utilities, you name it. And again, like I go back to the point I had made earlier, China has built it over 15, 20 years very strategically. So, and having said that, even after all these things, because of the lithium pricing, market pricing, every single Chinese LFP player have made losses in the last 3 years. But they are flooding markets worldwide because they have overcapacity, right? So how do you compete with that? So there are two things. One, like I just mentioned, there has to be a certain kind of government support incentive for the battery materials for us to actually come up with our capacities. And the second thing is the market has to realize, the government has to realize that we have to have a policy similar to what the US has, a 45x credit, that incentivizes the cell makers using domestic material, as their intake of the domestic materials goes up, it has to be linked with the PLI payouts. So that way, after a few years when the domestic capacity is online, they are incentivized to procure domestically rather than import. Also, we have to track, how this material gets in. We, in the US, they have what we call as the anti-dumping investigation. We have to make sure that if they are making losses, they cannot sell it at a certain price in India, right? It has to be a market-derived price.
No, thank you, Kalpesh. I think very interesting points on the models, and also what you said towards the end also, that how do we really create that level play. I have a couple of questions, but I'll complete one round and get back to you. Mr. Sandeep Hamilton, mineral demand is immediate, while the NCCM oversees acquisition and FTAs all carry long lead times. As a body that sees across the whole ecosystem, if you had to pick the 2 or 3 interim measures India should act on in the next 12 to 18 months to avoid a supply crunch, what would that be?
Okay, thank you so much, Pawan. And this large gathering here is the witness of the euphoria about the critical minerals per se. So if you see the world now, there are about 15 countries, they have their own critical mineral list. And there are about 35 countries, those who have developed a policy for the supply chain dynamics. So it has become a very big ball game altogether. But if you see core of all these lists which the various countries have made, there are 2 or 3 main themes which are emerging. One is the powertrain and the other one is the power pack. So today we are talking about the power pack, which is the batteries. And there are, of course, there are some emerging trends also, like for the critical minerals for the defense and aerospace. Also the critical minerals for the robotics and AI. So, and semiconductors. They are altogether very different thing. So, now coming to the main theme, which is the power pack. The main core of all this is the lithium. And at the moment, India has a very moderate deposit of about 1500 tons in South India, which is in Karnataka. Beyond that, we do not have much, but there are a lot of indications that in India, we do have the potentials. So what it has to be done? The main thing is, first we have to see the supply chain from outside, definitely. I mean, because the time is short and we are very soon we are going to have gigafactories, they will be needing the lithium. So that is the first thing, that supply has to be done. But if you see the supply chain overall, the main demand of the lithium is in the northern globe, whereas all the resources of the lithium are in the southern globe. So this makes a very unique dynamics, how we can come over it. Because if you see the largest lithium deposit in the world, which is the Green Bushes, south of Perth, that produces about almost like 90,000 tons per annum. And then the second one is the lithium triangle, which is in the Latin America. They are producing about 62,000 tons lithium right now. So they are in the southern globe. And so we have to work out a framework how we can develop this synergy of a supply chain dynamics. That's the first thing. The second one is we need to develop our own resources. That is very important, because suppose we want to do, like we have done some estimates. We are saying we are going to have 210 gigawatts of battery capacity by 2030. How much lithium is required? It's about 1,75,000 tons of LCE. It's a huge. Suppose we want to produce that. We need, for example, I can say spodumene from Australia, let's say. It's almost like 10,00,000 tons. Shipment of that to come to India for processing, it takes huge problems. So we need to develop our own resources in India. A lot of things are happening with Ministry of Mines, and a lot of projects, as our minister has also said, that we have so many projects are coming. What I feel, we should have a mission mode approach. Unless we have a dedicated mission mode approach, it will be very difficult to get soon this lithium resources in India. So what I mean by this is, like for example, I can give you the atomic energy. When uranium was needed, the Atomic Energy created Atomic Minerals Directorate, and its mandate was to look only for uranium. And today we have 425,000 tons of uranium, which can take care of our nuclear reactors. Like that, we should have a department, may not be particularly for lithium, but we can create a department only for critical minerals, where we can concentrate only on those which are needed for the future of the country. So that is one thing. The second one is, in earlier days, I just talked about the green bushes in Australia. This mine was started in 1888 and it was started for tungsten. And later in Second World War, the mine started producing tin. And today it is producing lithium. That means to say, these years in past century, the lithium was wasted and they were in dump. So, but the scenario has changed. We are into the green energy transition. So, we have to look like that. So, India do have a lot of copper mines, which has produced a lot of copper. But because that time technology was not there, because like for example, the cobalt and nickel, they are in few ppm. I mean, like they could be 200 ppm or 300 ppm. So they are now in waste dump. So India must also see that if we can harness by some technological innovations, for example, the biotechnology and other things, where without hampering the environment, we can have these the critical minerals which are needed for the battery from our own resources. So this is also very much required. And the third one is, I may say that coming down to the rare earths, India has a lot of potential, and India is the third largest resources of the rare earths. I can say 7 million tons we have. But this can go much more, because at the moment we are estimated only to the beach sands, which is about 7,000 kilometers of our coastal length, and we have about 138 beach sand deposits in India. But what we lack is the processing. So there it comes the problem, not for a mid-processing and refining. The problem comes for a metal and alloy production. So that is what is lacking, and we need to have those technology, or we need to develop those innovations. And in fact, one more thing I will say out of all those 3 points is that we must also bring the research in innovation in all this exploration, mining and processing and refining, which has been, I personally feel it is a bit lacking right now. So this is very much required, and a lot of countries have done miracles actually in this. Especially I can just give you a case of green pact, which has been taken by European countries, and now they have vast amount of the lithium pegmatites from which they can produce not only the lithium, but there are some the other critical minerals and rare earths minerals which they can produce. And they have also come out with one of a unique kind of a lithium deposit, which is having not only the lithium but about 15% of the boron. So that's all. Boron is also very much important in time to come. So we must look into these aspects. Thank you.
No, thank you, Sandeep. I think, what I learned and understood is also right. One is institutional framework. One is also this kind of trade and, international engagement framework. And then one is how do you source internally from alternatives, and also how do you bring capabilities. But I also come back, I think it really stops to midstream processing, which I have been hearing across, that you get the resources, but how do you really bring the midstream processing, actually make it work? To me, that seems to be really kind of what a priority is evolving also for the, yeah, sorry, you had a quick comment. Yeah, no, thank you so much. I'll come back. Priti, thank you for joining this session, and Energiva has been one of our great partners for so many years, and you have been leading this work around this whole critical minerals. I wanted to ask you that, India's critical mineral policy now spans several instruments, right? The NCCM with its exploration, the overseas acquisition, the stockpiling provisions, and Kabil's overseas asset purchase, bilateral mineral security agreements, all that we have heard, from battery scrapping to recycle position. So from a policy analysis standpoint, how well do these instruments contribute to more and more a diversified and resilient upstream and midstream for India's battery value chain? So I really kind of what Dr. Vijay and Kalpesh and Sandeep said, how do you really look at now policy to really make this work, and where do we really should focus? Is it a bouquet of all this that we really need, and what are those 2-3 priorities that India should focus on?
Thanks, Pawan. And this really puts me into a difficult spot, because the conversation or the fundamental logic of establishing the need of midstream refining, I think, has been iterated and then reiterated by all my 3 fellow colleagues earlier. But I think what the National Critical Mineral Mission is also doing is trying to bolster all the aspects when I try to look at it from a policy angle. Whether it's overseas acquisition by Kabul, we all know it's acquired one block in Argentina, Catamarca province. We look at recycling, the scheme has been announced. We look at processing, I think the ministry is in works, and soon we're about to hear about a capex incentive scheme also that they're working on. And when we talk about R&D and capacity building, we also see how the Center of Excellences have been announced, and all of them are taking great strides to enhance what I think Vijay sir mentioned for enhancing TRL level 4 and above. So I think while we're doing a lot, and we definitely can't compete with other countries, say China, because they have a legacy and they have been in the business, I think, of processing and midstream refining that we're currently focusing on since 25 years. So it has really taken a lot of vertical integration, a lot of full stack approach with lot of subsidies, all coming together to make that scale of economies at what China set as gold standard right now to reach that level. And India will take a while we try to focus and get there. But I think in terms of the gaps that you mentioned, so I think the intent is quite clear when I look at from a policy playbook, that we do want to secure critical minerals, but it also boils down to what are the major gaps or hindrances that are stopping this. So definitely midstream processing, because we are doing quite well on the upstream in terms of securing these minerals. But when it comes to technologies, I think we're still far in the game, and like I think we're already witnessing in terms of batteries, though MHI has announced a scheme, but in terms of say kind of even if we focus on battery minerals, which are lithium, nickel, cobalt, the fact of like sourcing spodumene and then processing it here and then ultimately exporting it out, are we just becoming a midstream processor in the entire value chain? Or does it make sense to set up CAM facilities for batteries and then probably export it? So I think those were few pinned questions that we were kind of also debating on with the ministry. But I think in terms of when we look at it in a long-term perspective and in order to reach net zero 2047 goals, I think the idea is to develop midstream capabilities with full force, and I think with Sandeep sir also kind of emphasizing that it needs to be done, but it needs to be done in a mission mode, where we kind of encourage our industry players to set up this processing capabilities and refining capabilities in terms of taking the in terms of taking the conversation ahead when it comes to when we just focus on critical minerals. So that's one definitely a reiterating point that I would want to make. The second bit I would want to make is on the project bankability and financing. Few folks from IFA, I think they've recently come up with a study which says that until and unless there is scale of these projects, the bankability and the economies of scale don't make sense. So I think pumping in a lot of bankable projects is also the need of the hour. And third and the last in the critical gap that I still see, and I think Abhinav sir would agree with me, is on recycling bit. While the ministry has announced the recycling scheme, there's a lot that needs to be done on the waste collection aspect, which still remains a very big question in terms of how do we actually set up protocols in terms of collection and get the volumes that we are actually foreseeing in the future to actually plug in into the recycling loop. So I think those 3 points played for me.
No, thank you, Priti, for laying down and articulating it so clearly, the 3 points. It also reminds me from my B school of Porter's theory of competitiveness, like to enter a market for an incumbent, what it really takes when the market is so established, right? Like, what are those entry points of, whether it's alternative, looking at your, suppliers and looking at where it comes from. I'm kind of hearing that framework also that, this is not something we can, it's not producing a cool drink. And even in with that market, that was a case study when we were looking at how Coca-Cola and Pepsi have such a huge control over the market, right? And it's kind of learning that to see how do you actually enter into a new market. Chetan, let me bring you in here, and I think Priti also touched upon the whole recycling bit, that India's EV fleet is still young, so end of feedstock is limited. Today's recycling capacity is a fraction of projected need. As the operator with the largest share of this market, what share of demand can recycling honestly meet near term? And where does the feedstock come from in the interim? Is it production scrap, imports, or consumer sales?
Thanks, Pawan. That's a great question. I think this is the question that we kind of keep debating on a daily basis with multiple folks. To answer this, I think in the short term, recycling is not going to fulfill the need of critical minerals for India. As multiple folks here have mentioned that it's a humongously fast-growing market where we are expecting roughly 200 gigawatt hours of batteries being placed by 2030. Recycling feedstock is going to fulfill roughly 10 to 20% of that. The penetration, Mr. Reddy also mentioned that it is 8.5% today. Last year it was close to 5%. So the pace of growth is almost 60% year on year. Last month, four-wheeler penetration was 6%, as in more than 6.5%. In fact, two-wheeler was 10%. Last year, these numbers were less than half of it. So the growth is very fast. The amount of feedstock that you are going to get in next couple of years is going to be limited. So the recycling is not a short-term solution. Having said that, do we leave it at it? No. So while 2030 is where the growth is continuously expecting, and beyond that as well. But beyond 2030, given that gigafactories are scaling up, there is significant amount of feedstock which is going to get supplied via recycling industry. So we need to put those structures in place today to have a proper recycling formal sector in the country. And I'm not just talking about production of black mass. We are talking about closing the loop. At this point in time, there are only certain steps in the value chain which are happening in the country, but most of the material after processing is still moving out. In terms of the feedstock, the production scrap, as the gigafactories are still scaling up, Ola, Amar Raja, Exide, Reliance, the feedstock is limited, but that is continuously increasing as these guys are ramping up their production. Consumer electronics, I think Priti touched upon that. The reverse logistics is a challenge because consumers are not aware how to process this material properly, where to dump them. Right now, your e-waste, your battery waste, everything or wet waste is going in the same dump yard, which is a loss of critical minerals to the society, but at the same time, it's also creating a lot of pollution. Mobility, most of the material that is coming in mobility, at least in four-wheeler, is production or warranty related issues. Two-wheeler first generation batteries have started coming back, but given the size of two-wheeler batteries being 1 kilowatt hour to 3 kilowatt hour, the quantum is not that humongous. So the point that I'm making is, in the short term, we have an opportunity to create those guardrails to have the proper system in place. Battery waste management rule is a right step in that direction, but there is a lot that needs to be done, and continuous deliberation keep on happening with MOE, FCC, how this can be made better. We are looking at Europe, the way they have formed their regulation in terms of recycled mandates. So in summary, short-term recycling is not the solution, but this is a very important piece which can't be neglected. Something beyond 2030, this is going to fulfill a lot of our dependencies that all of us are talking about. We have already spent good foreign exchange on bringing this material in India. Now it's up to us whether we will want to send it back for some other country's benefit, or we would want to keep it for our own benefit.
Thank you, Chetan. Little bit of rapid fire because I also wanted to get from audience. So Dr. Vijay, in the next 3 to 5 years, how do we accelerate lab to commercial transition?
It's a need of the hour, actually. We need these technologies yesterday. So we are actually looking at, as early as possible. So one of the things we can do it is, to bring in the industry and the institute connect, and then they have to work together, and then with the government funding. Obviously, the financial support, as mentioned, the amount of money you are raising it, and then, of course, then the user. So because it's also mentioned that the user is also learning, then the material has to be what kind of quality, what kind of purity, what kind of composition you have to come. And then the cell designs and then cell capacities are changing, I think, very, very quickly. We have been hearing that, the prismatic cell right now is 314 ampere hour, which was around 250 ampere hour 3-4 months back. So it's all changing very fast, with the changing designs, until unless we have to set a goal that, this is what the material, this is what the requirement by the companies, and then until unless that is done, so maybe the government or maybe the industries or the institutes, they cannot come, until unless there is kind of a constant assurance that, this whatever the material you are producing, and then it will be purchased by someone else. Otherwise, there is always a kind of a confusion or kind of an uncertainty that, when you are establishing a plant, then what capacity you have to establish, and then who is their customer, and then other things. So that's going to be a challenge. So until unless that is done, then it can be taken up very fast. Yeah. Thank you.
Thank you, Dr. Vijay. Kalpesh, real quick on what role will indigenous R&D, process innovation and manufacturing play in creating a globally competitive battery ecosystem, and what are the opportunities in India?
Yeah, I think some of it has been covered by Dr. Vijay. But basically, this is a very new industry, not a very standard industry. It's a tech product. Both the cell as well as the battery materials are technology products. So R&D plays a very fundamental and huge role. Unless you have the basic R&D setup, you cannot even progress to a stage where the customer is going to engage with you, right? So that's the first step. Now, what is also important is what I call as a process know-how. China has built this ground up. They had the R&D facilities, but they also have had pilot facilities. They had the first manufacturing plants that came up. So, just with money, you can think the know-how also compounds with all these years of manufacturing ability and the ecosystem being there. The cell makers also provide very valuable feedback. And all this is not possible. You cannot just go and buy a plant, put it here, and then expect to learn as you go from the manufacturing facility. So I think R&D plays a very, very critical role, as does the process know-how. The other important aspect about this is, look at what China did last year. They put export controls on not only the technology, on not only the products, but also the technology and the equipment. So, if you want to really sustain this industry in the long term, you have to have the know-how in-house. Very important.
Thank you, Kalpesh. Sandeep, what de-risking mechanism would actually move the investment?
If you take a critical mineral business, the risk factor is too high in this. Why? Because it's of basic nature. I'll just go back to 17th century. The mankind was using only 3 elements. That was iron, calcium, and carbon. Their percentage in nature, in their resources, is 50 to 90%. When the 18th century came, the man was utilizing the copper, tin, tungsten, and all these metals. They were like 4 to 5% in nature into the resource. Now we are talking about the elements which are not even 1%. In fact, their identification itself is a challenge into the nature. That's why we are dumping a lot of them. So you have to develop this ecosystem where you have the technology development, you have research and R&D, lot of to put into this, and you should also have a very good stream for upstream to midstream to downstream. Let me just give you a price index of the one of the rare element, which is neodymium. It was $179 in 2022 per kg. Now it is hardly $69. So it becomes a very risky, I mean, if you put a plant and the price becomes less than 50%, 60%, so it's a very, very risky. So what exactly it has to be done is something like other countries, and we have also done for our agriculture sector, we have created NABATE. Like that, there are some non-banking finance companies India has to look. It's not that it is only done for India has done for the agriculture sector, it is done for many other sectors also. So I think for this critical mineral sector, we need to have a dedicated kind of a national banking finance company for this. I think that will be able to solve the problems.
I really like that NABARD example on what can be done for critical mission also. And on a lighter note, maybe we need to go back to Black Panther Avengers to really see how do we get the critical minerals move in India. But Priti, let me bring you in quickly on, all these countries have their own model, right? China full stack, US Inflation Reduction Act, EU Critical Raw Minerals Act, Indonesia export ban. What does India need to do? How are you going to close the gap? I know I'm asking as if you can just decide, but how do we really think through this?
No, I wish we had a magic wand to this question and we could just swing it through our mission and the problems would get resolved. But I don't think there's a clear-cut answer to this. While we cannot compete with China, and I think in my earlier round of questions, I iterated that it has taken them 25 years. With EU, I think they're doing great in terms of setting targets, and I think Chetan also mentioned they have mandates. So maybe a bit of EU and a bit of US, what the US is doing in terms of the Inflation Reduction Act, and also kind of, in terms of taxes and subsidies. I think for India, the answer should be a mix of both. But again, suiting it to the Indian context. Like Indonesia, we cannot blatantly put export bans because we currently have none. Like we don't have lithium, nickel, cobalt present in the country, almost nil. And if we do that for graphite, I think India will see the light of the day, but I don't think we should be going that path. But in terms of a silver bullet, I don't think there is one, but all we need to do is also recognize and prioritize, I think across what the panel is also kind of agreeing is, identify the top priority critical minerals, which are, I think already we have a list of 24 critical minerals, but in terms of energy security and also the geopolitical situation which is playing out, maybe we need to look at what are the best sourcing, like upstream and midstream interventions that can really unlock the demand of critical minerals and technologies that will be needed to reach net zero by 2070. So I think it should be a mix of EU and US.
I like that, the mix, so we'll discover and remix it. Chetan, what market structures like recycled content rules or quality certification or functioning EPR market do we really need to so that recycled material is reliably accepted into new cell production?
So I think I'll just go back to Kalpesh's point. So it's already a very difficult technical problem, right? So we are trying to manufacture cathode active material, and at the same time we are also trying to do cell manufacturing. These two are happening simultaneously, where there is a huge learning curve because there is a country which has a huge lag up because of their experience. Now we are bringing third element of uncertainty into the mix, which is recycling material, right? Now, as I was earlier mentioning, and I think Priti also mentioned, that EU has mandates. So similar mandates are also there in India's battery waste management rule starting from 2028. So it mandates 5% of recycling material, which increases to 20% over a period of 4 years. Of course, the details are yet to be formalized by government, but that's at least part of the government policy at this point in time. Unfortunately, the value chain which is converting material to pre-cam material or cathode active material, that is not there. So when we talk about industry structures, these mandates which are out there in BWMR have to be more formalized or more detailed out in that sense. Second is there are no BIS standard or some alternate standard for recycled material or secondary material. For example, lithium carbonate, battery grade, what exactly is the standard? Of course, every cell manufacturer or CAM manufacturer will require their own tweaks around it, but there has to be a standard which has to be established so that the companies can say that they have the right quality of material which can then flow back into the supply chain. Third piece, which is battery Aadhaar, still in its formative age. This is something which has started happening in Europe again in the form of battery passports starting in 2031. India needs to put that into implementation so that the current OEM who are putting out the material into the market, they knows what is happening with their material once it reaches end of life. CAM producer or cathode active material manufacturer knows if they are taking recycled material into their supply chain, where is it coming back from? And from recycling perspective or second life perspective, we need to know where exactly the material has been used, what has been its SOH, is the material good for second life or it has to directly go for recycling, and it also helps us in giving a consistent feedstock. So the biggest problem for CAM manufacturer is getting consistent feedstock which is of the same quality. Unfortunately, recycling material, because it comes from multiple sources, it's a mixed feedstock. So the challenges there are more towards, I would say, towards ensuring that you have consistency rather than just about technical. And then there is a value chain which has to be established, where, as it was rightly mentioned, that we have PLI for cell manufacturing, but on CAM front we don't have much, at least at this point in time, which kind of goes back to the panel's point that midstream is where the focus has to shift now. All of us are focusing on very limited part of the value chain.
Thank you, Chetan, for summarizing that for me, that the focus is midstream. The panel will be here during lunch, so I would encourage everyone to really interact and, ask questions. So let's give a big round of applause to Dr. Vijay, Mr. Kalpesh Pandya, Mr. Sandeep Hamilton, Ms. Priti Shukla, and Mr. Chetan Jain. I know we are inching towards lunch, but I think we can do a little bit of louder applause for an excellent discussion this afternoon, very energizing, and it was a lot to learn from. Thank you. Back to Priti and my colleagues.
Thank you, Pawan, and thank you all our panelists for this engaging and insightful discussion. We would now like to invite Pawan to felicitate the panelists with a token of gratitude. We would also like to invite Ms. Akansha Tyagi from CEW to please felicitate our moderator, Pawan. Thank you very much, panelists, for the discussion. May we kindly request the panelists and moderator to remain on stage for the launch of our reports on battery Aadhaar in India. As India works to secure the critical minerals needed for a battery-powered future, ensuring visibility and traceability across the battery life cycle becomes equally important. To advance this conversation, we are delighted to launch 2 reports on scope and pathways for Battery Aadhaar framework in India. May we please request the authors, Ms. Chaitanya Kanuri, Dr. Parveen Kumar, Mr. Priyadarshi Singh, and Anubhav Mishra to kindly join us on the stage.
I'll also request Trupti and Balaji to also join on stage.
These reports draw on extensive stakeholder consultations and outline potential use cases, key data requirements, implementation challenges, and pathways for developing a robust battery data management framework for India.
No, not right now. Vijay, you want to announce? You have to announce. Who is it?
May we please invite Mr. Yogesh Kumar Sharma, sir, for the launch of the MOU?
We don't have the details of the MOU.
So, just briefly speaking about this, IIT Roorkee and WRI India will be entering into an MOU and on cooperation across the battery and electric mobility ecosystem. To mark the occasion, Dr. Yogesh Kumar Sharma and Mr. Pawan Mulukutla and Dr. Parveen Kumar and myself apparently.